In this lesson, 9.4, we're graphing monic quadratics in standard form. The success criteria: I can recall the features required to sketch a parabola, factorize a monic quadratic to calculate x-intercepts, and sketch a monic parabola in standard form. Recall that ax squared plus bx plus c is the standard form of a quadratic equation. The equation consists of a squaring term, ax squared, a linear term, bx, and the constant term c. Graphing a parabola in standard form follows a process that closely mirrors the steps used for graphing in factored form. The most notable difference is that if you have equations in standard form such as this one, you'll need to factorize first to calculate the x-intercepts. There are numerous ways to factorize a quadratic. Your teacher might direct you in the way that they prefer. One method is the decomposition method, which is shown below. What you need to recognize for a quadratic, which is shown here, is that the b value is 9 and the c value is 14. Hence, two numbers that multiply to give 14, that add to give 9, are 7 and 2. So we can decompose the 9x as 7x and 2x and factorize by grouping. So x outside of x plus 7 and 2 outside of x plus 7. The common factor here is x plus 7 with x plus 2 remaining. So our two factors are x plus 7 and x plus 2. Calculate and apply the key features of y equals x squared takes 6x plus 5 to sketch the parabola. So A is the y-intercept, you let x equal 0. So replacing x with 0, the y-intercept is 5. Now in standard form, the c value generally is the y-intercept. For the x-intercepts, let y equal 0. So I've let my equation equal 0. Now I need to factorize by decomposing. So two numbers that multiply to give 5, that add to give negative 6, are negative 5 and negative 1. Now they're in factors, I can apply the null factor law. X take 5 equals 0, and x take 1 equals 0. Solving, I'm going to add 5 to both sides in the first one, and add 1 to both sides in the second factor, so my x-intercepts are 1 and 5. The axis of symmetry is halfway between the two x-intercepts, so 5 plus 1 is 6, and half of 6 is 3. So the axis of symmetry is x equals 3. Now the vertex lies on the axis of symmetry, so I'm going to sub 3 into this equation. So subbing in 3, I end up with y equaling negative 4. So the vertex is 3 for x, and y equals negative 4. Now as the parabola, the a value up here is 1, parabola curves upward, like a smiley face type parabola, or a half pipe. So sketching the points, you've got 5 as the y-intercept, x-intercepts at 1 and 5, the axis of symmetry is there at x equals 3, and I've plotted the vertex, and to the best of my ability, or on a graphics calculator or graphing program, I've sketched the parabola. Calculate and apply the key features of y equals x squared take x take 6 to sketch the parabola. So press pause and calculate those four key features, and once you've done that, plot the points and sketch the parabola. The y-intercept, let x equal 0. So subbing in 0 for x, your y-intercept should be negative 6 or minus 6. The x-intercepts, by factorizing, we let y equal 0 first. Now factorizing, the product of two numbers needs to be negative 6, and the sum of those two numbers needs to be negative 1. So those two numbers are negative 3 and positive 2, which is now made, I've factorized the quadratic and can apply the null factor law. Null factor law is x plus 2 equals 0, or x take 3 equals 0. And hence, by solving, my x-intercepts are negative 2 and positive 3. The axis of symmetry is halfway between those 2 points due to symmetry. So 3 take 2 is 1, and half of 1 is 0.5. So x equals 1/2 is the axis of symmetry. The axis of symmetry is where the vertex lies on, so I'm going to sub in 0.5 to the equation. Getting a calculator out, the y value for the turning point is negative 6.25. So I've got the coordinates of the vertex. The a value for this quadratic was positive 1, so the parabola curves upward. So plotting those key points, the y-intercept, the vertex, the x-intercepts, and the axis of symmetry, we can sketch our parabola. It's also possible to calculate the axis of symmetry's location in standard form if you apply a general formula. X equals negative b over 2a. So that rule can help you find the axis of symmetry without having to factorize. The next section, let's calculate the key features, except this time we're going to find the axis of symmetry using the formula. So for y-intercept, let x equal 0. Subbing in 0, our y-intercept is -6. Now the x-intercept, we first let y equal 0. Now I have a negative a value here, so what I've decided to do is divide everything by -1, or factorize out the -1. So I have -1 outside of x squared plus 5x plus 6. Now two numbers that multiply to give 6 that add to give 5 are 3 and 2. That -1 is still the a value outside of these factors. In null factor law, you ignore the negative there because it's actually not related. X plus 2 is one factor and x plus 3 is the other. So my two x-intercepts are -2 and -3. Now this time I'm going to use the rule. So negative b over 2a, the b value is -5, so negative of that value is +5. 2 times -1 because my a value was -1. So my axis of symmetry is -2.5. Sub in -2.5 to the original function for x, and on a calculator, the y value, the y coordinate of the vertex is 0.25. Now this parabola is curving downward because the a value is -1, so it's been reflected about the x-axis. So sketching our points here, we have our turning point at -2.5 quarter, the x-intercepts at -3 and -2, and the y-intercept all the way down here at -6. Now it's a chance for you to have a try. The way you do, you're graphing y equals x squared plus 6x plus 8 by calculating all the key features and using the formula for the axis of symmetry. So the y-intercept, let x equal 0. Subbing in 0 for x, you should then have a coordinate of y equals 8. The x-intercepts, let y equal 0. So 0 equals x squared plus 6x plus 8. Now factorize, two numbers that multiply to give 8 that add to give 6 are 4 and 2. Now you have it factorized, you can apply the null factor law. So x plus 2 equals 0 or x plus 4 equals 0. Solving, my x-intercepts are -2 and -4. This time I'm not going to use the halfway point to find the axis of symmetry. We'll use -b over 2a. So my b value is 6 and my a value is 1. So substituting them into the rule, I'll have -6 over 2 is -3. So that's the axis of symmetry, which ironically lies between -2 and -4. Now I'm going to sub in -3 to the equation to work out the y coordinate of the vertex, and that is -1. So now we have the coordinates of the vertex. The a value, the dilation factor, is 1, so the parabola curves upwards. Now by plotting those points, we have a vertex here, our x-intercepts at -2 and -4, and a y-intercept of 8. Check how you went, and we'll skip on to the next one now. With our summary, let x equal 0 to calculate the y-intercept, and let y equal 0 to calculate the x-intercepts. Factorize the quadratic, and then apply the null factor law to calculate those x-intercepts. The axis of symmetry can also be found using the formula x equals -b on 2a. Plot all the key features and sketch a parabola, and remember, if the a value is positive, the parabolic curve opens upward, and if the a value is negative, the parabolic curve opens downward. Remember to like and subscribe to the channel, and if you need any more resources, check out Accelerate Learning Resources, where you can find things such as summative assessment, formative assessment, and student workbooks. Until next time, see you later.